We are at the Laboratory for Chemical Technology at Ghent University, and behind me you can see a pilot plant for CO2 recycling. This pilot plant can convert up to 1 kilogram per hour of CO2 into CO, which is a base molecule for the chemical industry. So the really innovative part of this technology is the chemical looping concept. So this process actually combines two chemical looping processes for CO2 capture and conversion.
When we compare it to the conventional process, which is dry reforming, we can actually convert 3 times as much CO2 per amount of methane. And by integrating multiple chemical looping processes, we can also combine reaction and separation, and doing this, we reduce the overall energy intensity of chemical processes. There are many opportunities for the super-dry reforming process, both in chemical industry, but also in steel industry. In chemical industry, we can go, for example, for the production of carbon-neutral fuels and chemicals. In the steel industry, carbon monoxide can be directly applied in the blast furnace, but can also be applied for the direct reduction of iron ore.
ArcelorMittal has around 9.4 million tons of CO2 emissions every year, and we are committed to reduce our emissions and to become one of the most sustainable steel producers in the world. And one of the initiatives we would like to sponsor or commit to is the super-dry reforming process, which can reduce our emissions strongly by using the already existing CO2 emissions, converting them to a more useful molecule CO, and this CO can then be re-injected into our blast furnace installations.
So we started off like 10 years ago on the lab scale, doing experiments with very small quantities, but we were always wondering, what will happen next if we want to really upscale this process. And that's where the Moonshot funding was really crucial, because it allowed us to build the pilot unit that you can see behind me, which really gives us more insight in the challenges that we will face in transitioning this technology to the industrial scale.
The next step would really be to go on site with an industrial partner and build a demo unit to also see what we can actually achieve with their exhaust gases.
Moonshot is very interesting for ArcelorMittal because it really supports us and also, for example, Ghent University in developing from this very low lab scale installation to a nearly industrial size operation. By 2030, we would like to reduce 35% of our emissions, and therefore we look at this pilot as a most promising technology for us to reduce our emissions.